The next bit of this, the third module is the hydraulic circuits. In this hydraulic circuit design, the syllabus is like this: the control of single and double acting hydraulic cylinder. Single and double acting, as you all know that the piston and cylinder arrangement, there are some of the cylinders are single acting and some of the cylinders are double acting. Means from the both sides the cylinder will be used for the pressurizing purpose. And also the regenerative circuit. Regenerative means as we all know that whatever the pressure we are applying on the circuit, that same pressure is utilized for the other circuit also. Regeneration, without making the pumping of oil from the sump or the reservoir, that oil is utilized for the other purpose also. That is called as a regeneration circuit. Pump unloading circuit, as we all know that after loading from the pump, the hydraulic circuit will be functioning. After functioning, the unloading of that the oil, pumped oil should be properly unloaded into the sump. That circuit also we are studying here. Double pump hydraulic circuit and counterbalance valve application. Counterbalance, as we know that in some of the cranes and some of the lifting equipments, we are all seeing from the day by day and in our life, there the used quantity of weight is lifted from one side. Other side, the counterbalancing is needed, because we don't know how much quantity of the weight is lifted in that side. Only the thing is that is designed to the different tonnages, different tons of capacity. But only the thing is counterbalancing. If you apply the counterbalancing weight to the other hand, then the equipment weight will be increases. Otherwise, what they are doing is hydraulic counterbalancing valve application is applied in the hydraulic equipments, hydraulic powerlifting equipments. And then hydraulic cylinder sequencing circuits. Sequencing is a very essential thing, because whole hydraulic circuit will not function simultaneously. According to requirement, according to the working nature, each and every equipment sequentially with a different timing they are operating one after the other. Suppose for this example, I'll give a good example for this in the lathe operations, the CNC lathe operations. If you want to make the turning and then the cutting and then the chamfering and then this counter boring and then boring and this knurling, some different thread cutting and the tapering, all these operations. In that, we can't do all operations simultaneously. First, what we are doing is in the machine shop lab, we are all studied that. Okay, machine shop lab, we are all studied that first operation is the holding of workpiece from both the jaws. That is done by the one operation, one valve. And then after holding, there is the tool post has to move towards the workpiece. Then the the tip should touch with the workpiece, and then we are giving some feed so that it is moving horizontally along with the workpiece, so that the cutting action takes place. After that, the various operations can be operated one after the other. We can't do the same operation at the single time in the same place, so that one after the other operation is needed. That is called as sequencing. Sequencing is nothing but the various timing of the various components. That sequencing operation circuit is studied in this year. Cylinder synchronizing. Cylinder synchronizing means sequentially cylinder should operate so that the pressure is applied differentially. The pressure is applied differentially. If the pressure from the pump is it is a large quantity of pressure is coming from the pump, that pressure is differentially bifurcated into the different circuits so that the whole pressure is utilized properly. And also the circuit using different methods, hydraulic circuit for the force multiplication. Force multiplication means in some cases the force, the pressure force may be the reduced, some cases pressure force may be increased. Multiplication or reduce can be done by using the different circuits. Speed control, hydraulic cylinder speed control. Some cases the excess enormous speed is not needed. The optimum and whatever the preset speed is should not cross. At the time the speed control hydraulic cylinder is essential. Cylinder circuit is essential, and also metering in and metering out and bleed of circuits, pilot pressure operated circuits, hydraulic circuit examples with accumulator. Hydraulic circuit is an arrangement of hydraulic element and devices interconnected in such a way to perform the specific function, as we all know that. Design of hydraulic circuit is to select various elements and devices of required types, capabilities, capacities, efficiencies, so that go into the cylinder circuit, that the elements or the devices carry out its intended function as desired and satisfactorily. Elements and devices includes the oil of certain grade and viscosity, and pumps and motors and connection and correct characteristics such as the speed, displacement, efficiencies, and valves, hoses, joints, connectors, so that the systems as a whole performs as a possible peak efficiency. Possible peak efficiency, including the hydraulic circuit not only contain these pipes and all those things, pipe connections, interconnections, all those things. It includes the oil's viscosity. Viscosity means thickness of the oil. If the viscosity of the oil is too high, then the pressure needed for that the transfer is more, so that the oil will not flow freely. Viscosity of the oil is too less. If it is too thin, then the oil may squeeze out. Other problems of the hydraulic circuits may occur, as we all know that. And the analysis is the process of verifying the performance of the circuit. After making any one circuit, we have to analyze and verify. Otherwise, the how the hydraulic circuit is working up to the satisfaction, and the efficiency of the hydraulic circuit is up to the satisfaction is there or not, we could not able to assess that. For that, what we have to do, we have to analyze and verify. And the analysis is carried out by the theoretical and practical approach. Theoretical and practical approach, as we all know that, after selecting the various elements in the hydraulic circuit, the various elements, as we know that, including pipes and the oil thickness, viscosity, everything, we have to count in the theoretical manner. Whatever the energy we are supplied into the circuit, and the same energy is utilized or not, how much of energy is lost, maybe in the form of the maybe loss, maybe in the form of this the thickness and then friction, whatever the things, how it is going to loss, we have to assess that. And the main objective of the hydraulic system is to find the specific and best possible solution to position, power, sequence, or the speed problem of any mechanical system, such as machine tools, lifts, cranes, and similar other mechanical, electromechanical equipments that are commonly used. The specific and best possible way of finding the solutions to the problems of these machine tools and lifts and cranes. These are the very few examples I am giving. The hydraulic system, hydraulics is a very old and vast field, as we all know that. Hydraulics is applied everywhere in the different fields. And then Electromechanical equipments. Electromechanical equipment, some cases the servo valves and different electromechanical, including this the automobiles and then the different cars, different equipments, electromechanical devices are used. And generally, problems encountered by the design may be movement of machine tool table and machine slides, press ram, and mechanical transfer of loads. These are the different problems can be solved by using hydraulics, proper design of this hydraulics circuit design. For instance, in a machine tool, if the different events or activities involved are loading and unloading of jobs, clamping and declamping of jobs, and forming operations such as the machining, pressing, movement of materials, tools, etc. Each of the above mentioned events, activities, the constitute a cycle. Designer has synchronized all these cycles into the single cycle. So he has to make the compact operation by including all operations. All operations means unloading of jobs, loading of jobs, and then clamping, declamping, forming operations. As I said in the the one examples I had given in this session, that is the lathe operations, the clamping, declamping, unloading, loading, and then this the machining operations are nothing but the forming operations. And then to carry out the designer carry out the different cycle of operations, designer have to consider some of the few factors while designing. Conformity to the design function, whether the desired functions are working or not, he has to confirm properly. And then level of performance and efficiency of the each component should be calculated properly, the designer. Safety and reliability. Well, the safety is important because lot of people are working around the hydraulic circuit, so that if there is anything happens, then the oil may be spilled on the peoples, and then it may cause the manual injury to the people surrounding to that hydraulic circuit. Ultimate cost benefit, because the cost should not be too high. If the cost is too high, then it is a very difficult task to maintain this the hydraulic circuit, and then to accommodate this hydraulic circuit in any machine tool industry and the industries, because ultimately all the peoples, those who are adopting these hydraulic systems for the conventional machines, then what they are thinking is they are estimating the cost. If the cost is too high compared to the conventional machines, then they won't prefer this. So that before designing anything, this cost estimation is a very essential thing. And also main units and ports of any hydraulic circuits are main parts of any one hydraulic circuits are power pack. Power pack is nothing but the hydraulic power pack comprises of oil tank main, and also hydraulic pump, the electric drive motor, mechanical couplings, and strainers for the filtering of the oil, and also these filters and coolers. Some cases after the circulation in the hydraulic circuit, the heat of the oil may be heated up. That heated oil should be cooled properly. Otherwise, maybe it may make the problems to these ceilings. And also the hydraulic power pack where the mechanical energy is converted into hydraulic energy, means the pump is sucked from the sump, and then it is supplied to the hydraulic circuit. And then the next part of this the hydraulic circuit is the control elements. As we all know that different controlling elements are nothing but the valves, various types of control valves, electronic control systems, the modify the energy and quantity direction of the fluid as desired at each stage of the point. These are the controlling the different the things in the controlling the different things in the circuit. And next is one is power drive units. Power drive unit consists of each element and device which converts the hydraulic energy imparted into the fluid at the power pack back into the mechanical energy in the form of work. These power drive units may be the actuators and motors. Here, actuators and motors are the converting the hydraulic energy into mechanical energy. And the last is system accessories. System accessories includes the hoses, pipes, and fluid conductors and filters. May also include the special accessories such as accumulators, power boosters, and heating and cooling systems, additional safety devices. These are the system accessories. Main parts of hydraulic circuits are over. Then all hydraulic circuits starts with a job to be carried out. Means the before designing any hydraulic circuit, we should know which job should be done by using the hydraulic circuit. After the analyzing that job means the work, means the loading, unloading, and then lifting, whatever you call it as the work. After the analyzing that work, according to the work, we have to design the hydraulic circuit. Job may include the lifting, loading, and pulling, pushing load, and the rotation of the tool head, and the clamping, declamping job, etc. All these are the work to be carried out. Therefore, the design of hydraulic circuit starts with the selection of actuator followed by other elements. First, before designing anything, first thing is you have to select the actuator. The control of cylinder. Controlling cylinder means the extending and retracting the cylinder, holding the cylinder in a particular position between the extension and retraction, holding the cylinder at the end of the either extension and retraction are called as controlling of cylinder, because all the actuators contains the cylinder and piston. And also the single acting cylinder. Single acting cylinder, the extension of the cylinder is due to the oil pressure acting on the piston in the cylinder. The retraction depends on whether the retraction is due to gravity or due to spring. If the retraction is due to gravity, the cylinder has to be placed vertically or inclined, but not horizontally, because the gravitational force which should act on the piston, then only it will come back. Otherwise, it won't come. So that it should be kept in the vertical manner, or maybe a little bit inclined. And if the retraction is due to by spring, then it can be placed in the any orientation. Any orientation, maybe vertically, horizontally, or maybe inclined. Any orientation, if you kept the cylinder, then the retraction takes place by means of spring force. Placing the spring return cylinder vertically, the speed of the retraction is faster than when placed in any other position, because if the spring retraction is kept in the vertical manner, then along with the spring force, there is a gravitational force also included, so that the speedy movement of piston takes place at the time of retraction. And here the diagram showing the single acting hydraulic cylinder. Single acting hydraulic cylinder. Single acting hydraulic cylinder. In this, See here, in this cylinder, there is a piston and cylinder arrangement. From the bottom you can move. There is a sump is there, and then strainer, and then pump. It is the bypass valve. If there is any excess pressure, here it is a single acting cylinder. The spring force is there. If you supply the pressure, then it is going through this. This piston is moved back, this, and then the spring force is against the spring force. There's a oil pressure is applied. Hence the piston movement takes place. This is single acting. Again, due to spring force, the oil, whatever the oil is there, it is going back to the tank. It is a tank symbol. Okay, these are tank lines. These are the springs. Spring, and then you see the circuit has a filter pump and the pressure relief valves, the direction control valve, and a spring return single acting cylinder. In operation with the cylinder, the normally retracted position. When the valve is operated manually, the pressure port opens, the pump flow is directed to the piston, and the end of the cylinder causes the extension of the cylinder. Once the extension is achieved, the pressure relief valve opens out and flow starts to pass through the pressure relief valve in the bypass line. When the direction control valve is deactivated, the pressure ports is blocked, and the oil from the piston end of the cylinder is routed to the tank line. The cylinder starts retracting under the spring pressure, and the oil flow back to the line.